So, good morning, everyone. Today I am starting the topic simple harmonic motion. So, in simple harmonic motion, first we have to understand the oscillation. That what is oscillation? Because everything starts with oscillation. Simple harmonic motion starts with oscillation. Okay. So, first understand what is oscillation, then we will see simple harmonic motion. Okay. So, oscillation is what is oscillation? So, oscillation is the motion of the body which is of the type in which the motion is to and fro on the same path. The particle is moving to and fro, means going forward and coming backwards, going forward, coming backwards. So motion of the body is to and fro on the same path. The path is not changing, and the motion is just getting reversed. Okay, whatever the motion was going forward is happening in the same in the backwards. Okay, so this type of this type of motion is known as oscillation. Okay, now oscillation becomes simple harmonic oscillation. Means oscillation was just a motion, it was not happening periodically, but if it happens periodically, okay, means after a regular time intervals, okay, then this is known as simple harmonic oscillation. Okay, why it is simple? Because it is happening on the same path, means one direction. Okay, so it is simple. Now simple harmonic oscillation, when a body repeats its motion after a regular time interval and the motion of the body is to and fro on the same path, the motion is known as simple harmonic oscillation. Okay, this simple word means the simple harmonic means simple means linear and harmonic means periodic. Okay, so harmonic means periodic. Harmonic functions are there in mathematics, so harmonic means periodic. Okay. Now the time interval in which the motion is repeated is known as period. Okay, so the time interval in which the motion has been repeated is known as the period of the oscillation, means the simple harmonic oscillation, because it is happening periodically. So the time interval in which the motion is repeated is known as period. Now simple means the simple harmonic motion. So simple harmonic motion consists of two parts, oscillation and harmonic or periodic motion. Okay, so oscillation is to and fro motion and harmonic is the regular time happening. Okay, means which is happening after a regular time interval. Okay, okay, let it write first. Okay, so in oscillation, when the oscillation is happening after a regular time interval, or means the oscillation has become harmonic or periodic, then that type of motion is known as simple harmonic motion. So in simple harmonic motion, the acceleration is always directed towards the equilibrium position or the mean position or the center or the origin. Okay, all are the same thing. Whether it's you say it a equilibrium position, or whether you say it a mean position, or whether you say it a center, or whether you say it's a origin. Okay, all are the same thing. So in the simple harmonic motion, the acceleration is always directed towards the equilibrium position or the mean position or the center or the origin. Now the equilibrium position means what? There are no forces acting on it. Okay, so there are no forces acting on it. The position is at the equilibrium. Okay, the forces are balanced and the net force acting at that point is zero. Okay, so the net force acting at that point is equal to zero. That's why it is called a equilibrium position. Okay, means that position is under no force. Okay, that position is under no force, and the net force acting at that point is equal to 0. Okay, there is no gradient at that point. Okay, there is no gradient at that point, means the magnitude, means the forces are equal everywhere. Okay, so forces are equal everywhere, and there is no net force acting at that point. So it is known as equilibrium position, or the mean position, or the center, or the origin. Okay, now in the simple harmonic motion, the acceleration is always directed towards the equilibrium position. Okay, and that acceleration has been represented by A is equal to minus of omega square into x. Okay, so omega square is the frequency. Okay, but this frequency is in radian per second. Okay, not hertz, it is in radian per second. Okay, omega is there, it's a frequency, but it is in radian per second, not hertz. Why is that? Because this concept is related to instantaneous center. Instantaneous center means what? Even the rectilinear motion that is happening, there is no motion that is rectilinear. Any motion is a circular one only, but rectilinear motion is the motion in which the center is at the infinity. Okay, that's why it's a rectilinear motion. No motion is rectilinear, every motion is a circular one only, and that's why it's omega. Okay, so radian per second, even it's the true form to and fro motion, it's represented by omega. Okay, now acceleration is equal to minus of omega square into x. Okay, so if x is positive, means the displacement is positive. Okay, moving from the center, you are going in the positive direction. If x is positive, then acceleration is negative, means it is pushing the particle to the center. Okay, so if the particle is moving away from the, means in the positive direction, if the particle is moving from the center, the acceleration is acting negative, means it is trying to pull the body to the center. If the displacement is negative, okay, if in the negative direction it's going, the acceleration is positive. Okay, means once again the body is means the body is pulled to the center. Okay, now magnitude of the acceleration is proportional to the displacement of the particle. Okay, that you have seen that acceleration is proportional to the displacement. Okay, so magnitude of the acceleration is proportional to the displacement of the particle from the origin, or the center, or the mean position, or the equilibrium point. Okay, acceleration of the particle at any distance x. Okay, looking from an inertial frame. What is an inertial frame? So inertial frame means the frame of reference in which the acceleration is 0. Okay, so in that frame of reference also there is no net force acting on it, so the acceleration of that frame of reference is 0. That's why it is called an inertial frame. Okay, so looking from an inertial frame means the frame of reference in which the acceleration is equal to 0, means on that frame of reference no forces are acting. Okay, means that frame of reference is also at equilibrium. Okay, means that frame of reference is another origin. Okay, okay, let it draw. Okay, so acceleration of the particle at any distance x, looking from an inertial frame, means the inertial frame of reference is the one in which acceleration is equal to 0, means net force is acting is 0. So inertial frame is another origin, another center, another anything like that. So another equilibrium position. Okay, so from that inertial frame of reference, okay, means the frame of reference whose on which the net force acting is equal to 0 and the acceleration of that frame of reference is equal to 0. So looking from an inertial frame of reference to this motion, okay, if you are looking at this motion from an inertial frame of reference, a simple harmonic motion you are that is acting on a system, means in a system if the simple harmonic motion is happening, and if you are looking at that simple harmonic motion from an inertial frame of reference, then acceleration is equal to force by mass, okay, is equal to minus of omega n square into x. Omega, or whether you understand it as omega only, omega is the frequency of vibration or frequency of oscillation or frequency of simple harmonic motion, okay, and n means natural, okay, when no attenuation is happening means it's a natural frequency or natural angular frequency or anything like that. So natural frequency, okay, so minus omega n square x, okay, or omega square x. Now acceleration is equal to dv by dt, okay, v is the velocity, t is the time, okay, equal to minus of omega square x or minus of omega n square x. Now force on the particle at any distance when displacement is x, okay, so force on the particle at any distance when displacement is x, then F is equal to minus of m into omega n square into x, okay, so this is known as minus into kx, okay, so this omega m into omega square term is known as k, okay. Now this k is the stiffness constant or a spring constant, okay. A stiffness constant means if in the torsion this is happening means torque by theta, or it is in the case of this force happening and extension is happening, so F by x, okay. So this is F by x or torque by theta in case of torsion, okay. So k is the stiffness constant or a spring constant, okay, and x is the displacement, okay. Now look at this figure. In this figure, this is an box or a mass or a body having a mass m, okay. Now this m has one center of gravity, okay, you know that a point function or a point object. So every object is treated as a point object assuming all its mass at its center of gravity, okay. So center of gravity is there for every mass, so we are taking that as the mean position for the displacement or for the movement of the body, okay. So we are taking the center of gravity as the origin. Now going in the minus x direction or going in the positive x direction, you know how the force is acting opposite to the displacement, okay. So if is opposite to the displacement, if the body is moving in this direction, the force applied will be in this direction. If the body is moving in this direction, the force will be applied in this direction, okay. Now the speed decreases and becomes 0 when moving away from the equilibrium and vice versa, okay. So if you are moving away from the equilibrium, then the negative acceleration is acting upon it, okay. So if the negative acceleration is acting upon it, means the speed will decrease and will keep decreasing because the force will keep increasing, and finally it becomes 0 when moving away from the equilibrium position, okay. And vice versa happens, means opposite of that happens when moving, means the speed will increase when coming to the origin, means coming to the origin the speed will increase, okay. Now when displaced from the mean or equilibrium position, the inertial or restoring force try to put it back to the equilibrium position. Means if the body is displaced from its mean position, then the inertial force or the restoring force, means this is the restoring for k into x, okay, or m into a, mass into acceleration, restoring force is the mass into acceleration, okay, or means k into x is the external force acting, okay, and m into a with the inertial force, okay. So inertial or restoring force try to put it back to the equilibrium position, okay. If the body is displaced from its position, the equilibrium or inertial force or restoring force will try to put it back into the equilibrium position. Now potential energy of a system. Okay, so block plus a spring that you have seen, the picture you have seen. So potential energy of that system. Okay, so at any extended distance, means whether you extend the spring or compress the spring using that moving that body. Okay, so at any position, compressed or extended, the potential energy of the system is equal to half into kx square. So k is the spring constant, okay, or a stiffness constant, or into x square. X square is a deflection, okay. In case of torsion, it will be theta, but in case of force is happening, k, spring constant. So in case of a spring constant, it's x displacement, okay. Okay. So potential energy of the system, block plus a spring at any extended or compressed position is equal to half into kx square. Okay, this has been represented by u, capital U. Okay, now displacement x is equal to a into sine theta, sine omega t plus theta. Okay, so a is the amplitude, means the maximum displacement. A, capital E is the amplitude, means the maximum displacement. Okay, omega is the frequency. Okay, t is the time, and theta is the phase difference or the initial phase. Theta is the initial phase when the time was 0. Okay, so when t was 0, that was the phase. So theta is that phase when t was equal to 0. Now kinetic energy is 0 at the extreme position. Okay, that I have said that the velocity is 0 at the extreme position, hence kinetic energy is 0 at the extreme position, and this kinetic energy is equal to half into mv square. Now v is represented by, because v is nothing but dx by dt, so dx by dt has been given by a into omega into cos omega t plus theta. Okay, now total energy, so total energy is always constant, okay, that's the law. The total energy is always constant, means potential energy plus kinetic energy is equal to half into omega square into a square. That you can do, that sine square theta plus cos square theta will give you 1, so that will become 1 by 2 into m into omega square into a square. Okay, now this energy that has been computed is all mechanical. Okay, this is a mechanical energy. Why this is a mechanical energy? Because all the energies related to the stress, strain, velocity, acceleration are mechanical energy. Okay, so these are all mechanical energy. Now assuming frictionless surface. Okay, frictionless means what? No resistance. Okay, there is no resistance happening, and then you have let the body to oscillate. Okay, so the oscillation is happening without any resistance. Okay, so assuming the frictionless surface. Okay, okay, so assuming the frictionless surface, this is the mean position or the equilibrium position represented by O. This is the positive direction and this is the negative direction. So maximum displacement that could happen is plus A, and the maximum displacement that could happen in the negative direction is minus A. Okay, plus x and minus x are the displacement from the mean position, means the normal displacement x, and A and minus A and plus A are the maximum displacement, means the amplitude. Okay, now the distance of both the extremes, okay, means the distance of the both extremes from mean positions are equal. Okay, whether it's x and means the, when the particle will oscillate, it will go plus x and minus x. Okay, it will not go x plus delta x and will come to x. No, if it has gone to plus x, it will come back to minus x. If it has gone to plus a, it will come back to minus a. If it has gone to x plus dx, it will come back to minus x plus dx. Okay, so that's like that. So distance of both the extreme position are equal. Okay, and the maximum displacement. Okay, so the maximum displacement possible with oscillation is known as amplitude. Okay, now the omega n that we were talking about, because omega is the frequency and omega n is the natural frequency. Okay, so omega n is the natural frequency of vibration, or natural frequency of oscillation, or natural frequency of simple harmonic motion. Okay, so natural frequency of simple harmonic motion means there is no damping. Okay, so no damp are there, and the body is allowed to vibrate freely, means it can oscillate freely. There is no surrounding to obstruct its vibration. There is no surrounding to attenuate the vibration, means there is no damping is there, and the body can vibrate freely, means oscillate freely. It can do the simple harmonic motion freely. Okay. Now both displacement and velocity are periodic function with a period of 2 pi. Okay, why it's 2 pi? Because sine and cosine function. Okay, so displacement is equal to a into sine omega t plus theta, and v is equal to a omega cos omega t plus theta. Okay, now omega t plus theta is equal to 2 pi plus theta, because the motion will get repeated after a 2 pi of interval. So omega t plus theta is equal to 2 pi plus theta. Anyway, this is called phase. Omega t plus theta is known as phase, and the phase is repeated after an interval of 2 pi, because this is a cosine function and a sine function which gets repeated after 2 pi interval. So omega t plus theta is equal to 2 pi plus theta, and omega into t is equal to 2 pi. So t is equal to 2 pi by omega. So t is the time period. Okay, and omega is the angular frequency in radian per second. Okay, now this omega plus t, omega t into theta, is called phase. Okay, so t is the phase at time is equal to 0. So theta is nothing but phi only, but at time is equal to 0. Okay, and omega is the, angular frequency or angular anything like that. So omega t into omega t is the time, and phi is the called the phase. Okay, so this is the phase that is happening in the simple harmonic motion. Okay, so the particle is at the mean position, and the initial at time is equal to 0. We are assuming at time is equal to 0, the particle was at the mean position. Okay, so this was the center, was the mean position. So at phi is equal to 0, f is equal to 0, a is equal to 0. No force acting, no acceleration is there, and phi is equal to 0. Phase is 0. After a phase interval of pi by 2, okay, the body has moved to the extreme position. Okay, so extreme position velocity is equal to 0. After a phase of pi, means 180 degree, it has returned to the same shape. It has returned to its own position. Again, after an interval of 3 pi by 2, it goes once again to the extreme position, but this time at minus a. Once again, after a phase difference of 2 pi, okay, means 2 pi means 360 degree. So after a 360 degree phase difference, it comes back to the same position that it has started. Okay, so this is the starting point and this is the end point, and both has come to the same point. Okay, so the phase of 2 and pi brings the particle to the initial position. Okay, because x and v are the sine and cosine function. Okay, so displacement and velocity are both the sine and cosine function, which gets repeated after an interval of 2 pi. That's why a phase change of 2 and pi brings the particle to its initial position. If it had been tan theta, because this was a sine function and cosine function, that's why it was happening after a 2 and pi interval. If it had been a tan pi function, means the function had been tan, then it had been n pi. Okay, the time period would have been decided by n pi. Now resultant force is 0 at the mean position. Why? Because acceleration is equal to 0, or equilibrium position. The mean position is also known as equilibrium position. So when the particle has reached its center, there are no forces acting on it. Okay, so that's why it is called equilibrium. That's why it is called mean position. Okay, now the definition of equilibrium. Okay, mean position and center. Okay, so equilibrium means no force acting, or forces balanced. Okay, so there are either no force acting, or there are all the forces that has been acting are balanced. Okay, so in that case equilibrium happens, and that's why the point is known as equilibrium position, because it is at equilibrium. Okay, now the mean position, because equilibrium position is also known as mean position. So why it is known as mean position? Because it is comparable to each one and there is no gradient with it. Okay, so it can accommodate with everyone, so it's a mean. so comparable to each other, there are no gradient, so it is also known as an equilibrium position. Now why it is known as center and origin? Because center and origin means it's born there. Okay, so no force is acting, no load, no stress. Load means what? External forces acting. Okay, so if there are external forces, to combat that external forces, internal forces are generated, and that internal forces is known as a stress. So when there are no load, there is no stress. Okay, so thank you.